Hello, everyone. So we're going to talk about automating an ML deployment, and it's a hands-on demo with Bodywork. So jumping into what Bodywork is, it's an open source tool designed to make ML model deployment and automation much easier. Instead of manually setting up environments and worrying about how to scale your models, BW takes care of these tasks for you. One of the biggest challenges in ML is moving models from development to production. So BW automates this process, handling deployment and scheduling jobs for you. This means your model can run on its own without needing any manual intervention. BW also runs on Kubernetes, but you don't have to be an expert as it simplifies the process for you. Instead of writing complex scripts, you define your workflow using a simple YAML file. This makes it easy to manage and adjust different steps of your pipeline. A common problem in ML is that a model might work on your computer but fail in production. BW solves this by using containers, ensuring that everything runs the same way no matter where you deploy it. And if we need to update the model or like fix a bug, BW works with CI, continuous integration, and CD, continuous deployment, to track changes and deploy updates automatically. So this makes the model management much more efficient. So who can use it? BW is designated for data scientists, DevOps teams, and small organizations and individual practitioners. So data scientists can focus on model development without like worrying about the infrastructure, as BW automates deployments without requiring Kubernetes expertise. DevOps teams benefit from seamless CI/CD integration, making it much more easier to manage multiple ML services within a single Kubernetes infrastructure. And for smaller teams and individual users, BW is a cost-effective open source solution. So like it'll help them make the model deployment much easier, and it's also user friendly. So why BW over other tools? Uh, Compared to so we're going to take Kubeflow as an example. So Kubeflow is a powerful tool, but it can be complex to set up and maintain. So BW on the other end is much simpler. You don't need to need to know deep Kubernetes knowledge or to get started on. So which makes it more accessible for teams that just want to deploy ML models quickly. One of the main goals of ML Ops tool is to automate tasks like training, deploying, and scheduling models. So BW does this seamlessly, reducing manual work and ensuring models run smoothly in production. Both Kubeflow and BW run on Kubernetes, but BW simplifies the process. Instead of requiring multiple components like Kubeflow does, BW works directly with Kubernetes to provide a lightweight, scalable solution. BW is also designed to work well with CI/CD pipelines, meaning it can automatically update models whenever there's a new version. This ensures continuous improvement and reliability of ML models. So while Kubeflow is a great tool for large-scale ML workflows, BW is a lighter, simpler, and more efficient alternative.
Uh, so till now we have understood that Bodywork is a command line tool that deploys machine learning pipelines into Kubernetes. So it removes the need for you to build and manage container images for any stage of your pipeline. Let's look at the Bodywork workflow. What are the stages and what are the steps involved? So as given in the workflow, we have uh, various components like steps, stages, and workflow, which comprises of bodywork, and this all is comprised in a Kubernetes environment. So the first one is workflows, which represent the entire machine learning pipeline. Steps are groups of related tasks and which are executed sequentially. Then stages are individual tasks within each step of it. So for example, let's take first step. So in this one, I'll have three stages. The first one is extraction, cleaning, and feature engineering, which comes under data preparation, which is my step one. The second step is model training and evaluation. So it will have three stages, which are training, tuning, and evaluation. And for the third one, I'll have deployment, API serving, and logging. Yeah. So to give an overview how it is being used in Bodywork and how we have used it to deploy automated machine learning model, we had to first organize ML codes and dependencies. For that, as Sneha mentioned, we have used the YAML Bodywork YAML file. Then containerization, which packages code into Docker images. Third is Git-based integration. We had to use GitHub to deploy and sync automatically for version control and rollbacks. In case of any issue, it can immediately roll back the version. The fourth one is deployment to Kubernetes, which runs pipeline in the pods and it provides the controlled scalability. Then we have automated scheduling, which is done by the cron jobs in Kubernetes. Then for monitoring and logging, we have a command in Kubernetes which will come in the next phase of the presentation. Then the lifecycle management, which is similar to what we do in project management. So to install and work with Bodywork, we actually had to research a lot regarding what tools and what frameworks we need before we can work with Bodywork. So it requires a very specifically Python 3.8 version. It took us a lot of time to figure that out because we were facing a lot of issues. Then we also need Bodywork CLI command line. So using the pip installation, we can install Bodywork. Then Minikube, which is a Kubernetes cluster, we have to use with Bodywork. Then there is Nginx, which is a API gateway to the cluster, how we should interact and configure the cluster. Then we have Docker, which is required for containers, of course Kubernetes, and we have GitHub for version control and pipeline integration. Okay, so the first step was to install the Bodywork through the pip install command in command prompt. If we want to test how our Bodywork, oh, sorry, if you want to test the version of the Bodywork and whether it's installed perfectly or not, we can use the command which is given here, which is Bodywork help. Then through the Bodywork YAML file, we can define our pipeline structure. Then the easy way to get started with Kubernetes is through the Minikube. And if we want to see the high level cluster information, we can give the command Minikube profile list, which will give us the Docker information, runtime, and IP address, everything. Next, if I want to verify the Minikube status, whether it is up and running, I can do it with the Minikube status command, and it will give me the type, host, and API server configuration. The next is to run this pipeline or to interact it with the command prompt, we need to use Docker. For the same reason, we had to install Docker as well. And in Kubernetes, there is an option in the settings to enable the Docker configuration for the Bodywork configuration. So that also we had to enable through it. So this is the screenshot for that. The next is Nginx, which is an API gateway for cluster. Uh, Basically it will route to HTTP requests to internal services created by machine learning pipelines. And there is kube control tool, which also we had to install, which will let us know the Kubernetes cluster, which can control the Kubernetes cluster and get the basic information. So these are the commands which we put for installing the kube control and Nginx. Now, the last step is I need to monitor my pipelines. I need to read the logs if there are any errors. For that, we had to use the command minikube dashboard. If you see this highlighted in red, this is what it creates as a URL. And through the URL, we get a dashboard below where we have all the logs tracked of what is the status of the pipeline deployment and so on.
Since we're short on time, I'll just summarize. So basic lessons that we learned through this is like plan. So first of all, we need a strategic planning. So you need to plan strategically before you start using Bodywork, as you know it involves a lot of steps. And second, you need to like continuously monitor and like optimize the tool. And finally, it's since it's a collaborative tool. So like a lot of people, a lot of teams will work together. So you need to be like open minded with working with different teams. And some of the advantage of this tool is that it saves time by reducing manual work, and it also helps teams deploy models faster without deep Kubernetes knowledge. And finally, it gives team full control and flexibility over their ML pipelines, and it ensures models are always up to date and performing well. It does come with some challenges. So organizations with limited ML or DevOps experience may find it challenging. So the solution for that is maybe investing in training or collaborating with DevOps professionals. And the second one would be running a Kubernetes cluster can increase infrastructure expenses and require maintenance. So in order to solve that, you can consider using a cloud managed Kubernetes resources.
Yeah, and also, Professor, as this is MLOps class, so through this tool, we could actually get idea about how can we do the intersection of machine learning and development and operations, because it required us to have the knowledge of all the operations, how to configure it together, and how to run the ML models.
Thank you.
Thanks so much. So much I'm actually my project is very similar to yours. It's more like a technical question. So when you set up the Kubernetes clusters, like how did you configure the ingress? Did you use Ambassador or
Sorry,
the other option?
I didn't get the last.
How did you like configure the ingress of your cluster? Like,
So we have a command for that,
oh,
and that I can provide it to you if you want. So you can configure it through the command. I think we had it in the presentation as well. The Minikube add-ons enable ingress.
The first line.
Yeah.
thank you.
Yeah. Automated scheduling. So we have Kubernetes, which has cron jobs through which automated scheduling is handled. If there is any retraining required, you can use it. We haven't explored that, but since it was there in our research, I know of the term cron jobs.
Thank you.
Thank you.